Hello everyone, my name is Dennis Rausch, and today we're going to be talking about the AP Calculus BC FRQ 2007 number 3. So here's what the problem looks like. We're given the graph of the polar curves of r is equal to 2 and r is equal to 3 plus 2 cosine theta, which look like that and like that respectively. And we're also given the intersection points, which are theta is equal to 2 pi over 3, which is out here, and theta is equal to 4 pi over 3, which is down here. Quickly looking over the problems, we see that for the first one, what we have to do is find the area inside the graph of r is equal to 2, and also inside the graph of r is equal to 3 plus 2 cosine theta, which is just this shaded area here. For b, what we're going to have to do is find the value of dr over dt at theta is equal to pi over 3. And for c, what we're going to have to do is find the value of dy over dt at theta is equal to pi over 3. So we know that this is a polar question and that we're going to have to apply integration to find the areas, and we're also going to have to differentiate parametric or polar equations. Jumping right into problem A. Here what we want to do is find the area of R, which is this shaded region here. The way we should approach this problem is to split up into two simpler areas, this green one here and this red one behind it. Remember that the area for polar is 1/2 times the integral of a to b, which are just the endpoints, of r squared d theta. To find the area of this red region, what we're going to do is we're going to plug it into the polar equation, which is 1/2 times the integral from 2 pi over 3 to 4 pi over 3, from here to here, of 3 plus 2 cosine theta squared d theta. So the reason we're using this r is because we're integrating along this limit here from 2 pi over 3, this point, to 4 pi over 3, this point. To find the rest of this red area, we're going to use the same concept, but this time, instead of 2 pi over 3 to 4 pi over 3, we're going to use 4 pi over 3 to 8 pi over 3. The reason we can't use 2 pi over 3 is because if we use 2 pi over 3, it's like we're going to be integrating backwards like that. So instead, we just add 2 pi, and it's going to be like we're integrating like so. We're using r is equal to 2, so our final equation for this red area is 1/2 times the integral of 4 pi over 3 to 8 pi over 3 of 2 squared d theta. Now, the total area, shaded region R, evaluates to this, which when we plug into our calculator, we get 10.3705. Looking at the scoring guidelines, there's 4 points total for this problem. We get 1 point for the area of the circular sector. We get 2 points for the integral for the section of the limison. 1 point goes out to the integrand, which is the inside here, and 1 point for the limit and the constant. And there's 1 more point for the answer. So for this question, we got all 4 points. Moving on to problem B. A particle moving with non-zero velocity along the polar curve given by r is equal to 3 plus 2 cosine theta has position x of t, y of t at time t, with theta is equal to 0 when t is equal to 0. This particle moves along the curve so that dr over dt is equal to dr over d theta. Find the value of dr over dt at theta is equal to pi over 3 and interpret your answers in terms of the motion of the particle. So, dr over dt, which is actually just dr over d theta, is simply the derivative of r in terms of theta. So, using simple differentiation, we get negative 2 sine theta as our derivative. At theta equals pi over 3, the dr over dt is equal to negative 2 times sine pi over 3, which is just negative root 3. As a quick sanity check, we can check that the r's are decreasing as theta increases on both polar and on Cartesian coordinates, so this answer makes sense. We can't forget to interpret our answer in terms of the motion of the particle. So the rate of change of r is negative root 3, as we calculated down here, and the position of the particle at theta equals pi over 3 is 4. Therefore, the particle is moving towards the origin. Looking at the scoring guidelines, there's only 2 points for this problem. One goes out to the derivative at theta is equal to pi over 3. This is actually just negative root 3. And another goes out for the interpretation, which says that the particle is moving closer to the origin since dr over dt is negative and r is greater than 0 when theta is equal to pi over 3. So again, we got both points. For C, we have to, for the motion of the particle described in part B, dy over dt is equal to dy over d theta. Find the value of dy over dt at theta is equal to pi over 3 and interpret your answer in terms of the motion of the particle. So, we have to know that y is equal to r sine theta. Plugging in r, we get y is equal to 3 plus 2 cosine theta times sine theta. We can just plug this into our calculator and find that dy over d theta, which is actually dy over dt in this problem, is equal to 1/2 at theta is equal to pi over 3. And again, we have to interpret our answer in terms of the motion of the particle. So what we do is we find y of pi over 3, which turns out to be 3 plus root 3 over 2. And we find dy over dt is 1/2. So the particle is therefore moving away from the x-axis. So the scoring guidelines, there's 3 points for this problem. There's 1 point for the expression of y in terms of r, which is 3 plus 2 cosine theta times sine theta. There's 1 point for dy over dt at theta is equal to pi over 3, 1/2. And there's 1 point for the interpretation. So we got 9 out of 9 on problem number 3. Thank you for listening. Hopefully you understood. If not, you can ask me or Mr. Knutsson, and you can work on the related problem which will be linked in this video.